Hello lovely viewers, welcome to another section of my tutorial. And I have a problem in applied electricity, and this is a problem under Thevenin's theorem. And now the problem says it is desired to use Thevenin's theorem to find the current in the 5 ohm resistor of the circuit below. So he's saying that what is the value of the VTH, find the value of the RTH, and determine the current in the 5 ohm resistor. So Thevenin's theorem is a theorem which we use to find the current through a single resistor in a network of several resistors connected together. So to find or to use the Thevenin's theorem, you first remove the resistor into consideration, or the resistor which you are finding the current. Then also, after you create an open circuit and you find the voltage across that open circuit, which we call the VTH, that's Thevenin's voltage. Then also you find the RTH. To find the RTH, you have to deactivate all the sources and also find the resistance across the open circuit at where the resistor has been removed. So let's see how you go about this. So the first step is to remove the resistor, and the resistor you're going to remove will be the 5 ohm resistor. So let's see. You redraw the circuit, and you have our 2 ohm resistor coming down. Have this. Then here will be an open circuit. You remove the 5 because that is how the theorem go about its calculation. So you have our 10 volts here, the 2 ohm will still be here, 2 ohms will be here, and you have our 2 ohms, you have our 3 ohms, you have our 2 ohms, then finally 7 volts here. Then we put our VTH here. So now this is acting as a virtual source. So we call it VTH and we assign a direction for it. So let's see. We have to find the value for this VTH. So we can apply the Kirchhoff's rules to get the value for the VTH. So let's see, this source will produce a current, say I1. I1 will pass through this 2I2, but upon reaching this junction, this place is an open circuit, so it has no other choice to come down and also come back to its source. So for here to 10 volts here will produce its current, let's say I2. I2 will come, and I2 is saying that there is an open circuit here, so it will move. So I2 will come and it will pass through. Upon reaching here, it will return back to its source because here is an open circuit and there is no continuity. So let's see, we have to find the value for I1 and I2. So I have to take this loop to find my I1. Taking that loop, I'll get my 7 to be equal to 2I1 plus this voltage drop. The same current is passing through, so I also get 3I1. Therefore my 7 will be equal to 5I1, and therefore my I1 is equal to 7 over 5 amperes. For my second, this part, I'm going to have this as my loop. So I'll have my 10 volts to be equal to a voltage drop here, 2I2, plus the same current will pass through here, 2I2. Therefore 10 will be equal to 4I2. My I2 will be equal to 10 over 4, and this is equal to 5 over 2 amperes. So now, since I'm having my two currents, I'll simply take this loop to find my VTH, because I know that VTH acting as a source and using the Kirchhoff's rule in a closed loop, VTH here will be equal to the voltage drop in this loop, and that will be 3I1 plus, now when you consider this resistor is parallel to this branch. There is no current passing through the upper branch, so there is no current that will be returning through here. So this place there is no current passing through, therefore the voltage drop here is 0, so it's not considered, because the current will pass through and come back here to the current will pass through and go back, so there's no current passing through here. So to be taking this loop, I'll get 3 multiplied by the I1, which is the current through, but the 2 will be 0, so I'll not write it, So plus these two with the current I2, and this is the same as 3 multiplied by my I1 is 7 over 5 plus my I2 5 over 2, and this is the same as 21 over 5 plus 10. So here will cancel, I get 5. So what will I be getting? 21 on 5 plus 5, and that's giving me 9.2 volts. So my Thevenin's voltage, or the open circuit voltage, is going to be 9.2 volts. To find my RTH, I have to deactivate all the sources, so I'll remove all the sources, and when you are having a voltage source, it will be a short circuit. If it's a current source, it will be an open circuit. In our example, you are having voltage sources, so it's going to be short circuit. So let me redraw and create short circuit at where the voltage sources are. So I'll get this, then my open RTH here, I'll get another short circuit here like this. Here is 2 ohms, 2 ohms, 2 ohms, 3 ohms, then 2 ohms. So this is how you do. So your RTH is the resistance across this. So you are going to find the effective resistance of this network. It can clearly be seen that these 2 ohms and these 3 ohms are in parallel, because there's a node here, and when you go through, you are not meeting any other elements. Here too, they are parallel. So rewriting the circuit, I have my RTH, my here, then my effective resistance here. So to get the effective resistance here is 2 times 2 over 2 plus 2, and this will give me 4 over 4, and that will give me 1. So this place is 1 ohm, and here 2 is going to give me 3 times 2 over 3 plus 2, that is 6 over 5 ohms, and here is 2 ohms. So now this are now in series. So my RTH is finally 6 on 5 plus 2 plus 1. This is the same as 1.2 plus 2 plus 1, and that will give me 4.2 ohms nicely. So I have my RTH to be 4.2 ohms here. So the question is asking for the determine the current in the 5 ohm resistor. To find the current in the 5 ohm resistor, you know that Thevenin's circuit, or Thevenin's equivalent circuit, you are going to have our Thevenin's voltage here, with our Thevenin's RTH in series with the resistor RL like this. So we have our VTH here. So from here we can find the current through by simply VTH, that's our I is simply VTH over RTH plus our RL, and that will give us our VTH in the question is 9.2, our RTH, which is 4.2, plus the resistor into consideration, that was 5 ohms. This will be 9.2 over 9.2, and that will give us 1 amperes. So the current to the 5 ohm resistor is 1 amperes. This is the end of my video. Thank you for watching, and please kindly subscribe and share.